You swipe across your phone's touchscreen thousands of times every day, but how does it actually work? Today, I'll explain it clearly in just 2 minutes. Imagine a copper plate. If you apply a positive charge to it, a nearby copper plate will develop a corresponding induced charge. Between copper plates A and B, positive and negative charges create a curved electric field. This is called the fringe electric field effect. Let's call plate A the driving layer and plate B the sensing layer. When a finger approaches, it intercepts part of the electric field. Some of the induced charge transfers to the finger, causing the sensing layer B to receive less charge. In reverse, if you detect a decrease in charge on the sensing layer, you can tell that a finger is nearby. Congratulations! You've just discovered the basic principle behind a smartphone touchscreen. But one pair of copper plates can only tell that a finger is nearby. It can't determine whether the finger touched here or there. So you come up with a clever idea. Shrink this pair of plates and copy it dozens or even hundreds of times to cover the entire screen. Now, by checking which sensing layer loses charge, you can determine where the finger is touching. However, another problem appears. If all these driving and sensing layers work at the same time, power consumption becomes huge. The phone's calculations increase dramatically, and the response slows down. So what can you do? You connect all the driving layers vertically into columns and all the sensing layers horizontally into rows. This reduces hundreds of separate lines down to just dozens, lowering complexity and power consumption. By checking which sensing row experiences a charge drop, you can determine which row the finger is touching. But there's still a problem. Knowing the row alone isn't enough. There are many points along that row. Where exactly is the finger? Then you think of a brilliant solution. Power the driving layers one at a time. At any given moment, only one driving column is activated. Column 1, then column 2, then column 3, then column 4. Each powers on in sequence. When the chip detects that the sensing layer in row 7 loses charge while column 5 is active, it instantly identifies the finger's position at column 5, row 7. Pretty smart, right? You install this system into a phone, but a new issue appears. Dozens of copper strips covering the screen block the display, making the image impossible to see. So you need a material that is both transparent and conductive. Luckily, there's a material called indium tin oxide, ITO. It has good electrical conductivity and high light transmission, making it perfect for the job. You replace all the copper strips with ITO and cover everything with a protective glass layer. Congratulations! You've just invented the projected capacitive touchscreen. And with that touchscreen, you can tap like on this video.